In this question, it is given that let f takes R to R be a function defined by this, and g takes R to R be given by gx equal to fx plus 2 minus fx minus 2. If n and m denote the number of points in R where g is not continuous and not differentiable respectively, then n plus m is equal to dash. You have to fill in the blank. The first point to be noted is fx is an even function, because it is clear that if we write minus x for x, both these definitions remain same. Hence, I can say fx is an even function. But actually, we have to discuss about gx. And you should note that gx is an odd function. How? See, g minus x will be equal to f minus x plus 2 minus f minus x minus 2. That is f x minus 2 minus f x plus 2. Note that here I have used this thing that f minus x is equal to fx, because f is an even function. For getting this expression from this, I have used this equation. And because it is g minus x, hence I can say g minus x is equal to minus of f x plus 2 minus f x minus 2. That is, I get g minus x as minus gx. Hence, g is an odd function. Hence, to discuss about the number of points of discontinuity and non-differentiability of gx, we just find the number of points of discontinuity or non-differentiability only on right hand side of y-axis. Because the graph is odd function, the same will be the number of points on left hand side also. And therefore, to draw the graph of gx, I suppose x as greater than equal to 0. Therefore, if x is greater than equal to 0, gx becomes x plus 2. And because x is positive, fx plus 2 will be more than 2. And for positive values of x, which is equal to 3 into 1 minus x by 2, if x is less than equal to 2 and greater than equal to 0, and 0 if x is greater than 2. And again, because I have supposed x as positive, according to this definition, x plus 2 will be more than 2. Hence, the value of this will be 0 minus. As I know that f is an even function, hence onward, keep in mind that this is same as f 2 minus x. And because I have supposed that x is positive, if x is less than 2, I'll be using f 2 minus x. And if x is greater than 2, I'll be using x minus 2. Therefore, first case, if x lies between 0 and 2, instead of this, I will write this thing. That is f 2 minus x. 2 minus x is a positive number. And because 2 minus x lies between 0 and 2, using this, I'll be getting 0 minus 3 into 1 minus 2 minus x by 2. That is equal to minus 3 into x by 2. That is minus 3x by 2. And but 2 less than equal to x less than equal to 4 is there, it will be still 0. Then instead of this, I will use this because x will be greater than 2 and less than 4. Hence, this will be positive and this will be negative. Therefore, I'll be more convenient with this. Actually, agreed, both are same. For the value of x from 2 to 4, the value of this will lie between 0 and 2. Hence, again, I'll be using this. Therefore, if 2 is less than equal to x less than equal to 4, the value of gx will be again 0 minus f x minus 2. And because x minus 2 is lying between 0 and 2, hence using this, I will be getting 0 minus 3 into 1 minus x minus 2 by 2. Note that x minus 2 is positive. Hence, I will be getting minus 3 into 4 minus x by 2. And this means 2 is less than equal to x less than equal to 4. And if x is greater than 4, then the value of this is also more than 2. The value of this is also more than 2. Hence, both of them will have the value 0 from here. Therefore, I conclude that gx is equal to 0 minus 0 if x is greater than 4, that is equal to 0. Hence, let us draw the graph of gx for positive values of x. Clearly, the value of gx is minus 3x by 2 for the values of x from 0 to 2. Hence, it will be of this type. 2 and here minus 3, because when x will be 2, the value of gx will be minus 3. And when x lies between 2 and 4, the value of gx will be this. And it is also clear that for the value of x equal to 2, both of them will give same answer. Hence, the graph will start from here. And because this is 3 by 2x minus 6, that is slope is positive, y-intercept minus 6. Therefore, the graph will be this thing. This side graph will not be there because I have supposed x is lying between 2 and 4. It is 4 here. And for x more than 4, the value of gx is 0. That is this thing. And because gx is an odd function, I had concluded in the very beginning, therefore the graph on left hand side of y-axis will be there in second quadrant, that is and this point will be minus 2, this will be minus 4. Here 2 comma minus 3, and here it will be minus 2 comma 3. And because of symmetry, whatever is this angle, same will be this angle. Hence, I can say this is whole one straight line. Therefore, I can easily say that there is no point of discontinuity, but non-differentiability is at this point and this point and this point and this point. Obviously, if there are two points of non-differentiability on right hand side, there will be surely 2 points on of differentiability on the left hand side also. Hence, total number of points of non-differentiability will become 4, and there is no point of discontinuity. Hence, the value of n is 0 and the value of m is 4. Hence, the value of n plus m is 4.